Hello, welcome to my channel. We will be doing question number 1 of chapter 13. It's vectors, chapter of vectors. Okay, so this is pretty straightforward question, not difficult at all. We are given that the position at the points A and B relative to an origin are this. So OA vector, position vector of A with respect to the origin O. This is given as minus 2i. I is a unit vector along x-axis plus 17j. J is the unit vector along y-axis. And similarly, OB, the position vector of point B, this is known as, this is given as 6i and plus 2j, plus 2j. Okay, respectively. Find the vector AB. Okay. You see, I assume that there's some point A and there's some point B over there. So OA is given, this is O, and OB is given. So you can see that this is AB vector. Okay. So you agree that OA plus AB is equal to OB. So from here you conclude that AB vector is going to be OB minus OA. Okay, so whenever we have to find vector A to B, so first we find the position vector of B minus position vector of A. Okay, now what is OB vector? It is 6i plus 2j, and from here I have to do the subtract this one, minus 2i plus 17j. So this will give us 6 plus 2 is 8i, and 2 minus 17 is minus 15j. Okay, this is my AB vector. So this was part 1. Okay, so we can say that I am doing 1 here. Okay, now part 2, it says find a unit vector in the direction of AB. Okay, so let me write it this unit vector in the direction of AB. Let me call it n hat. And how do we find this vector? Okay, so if I take the vector AB and divide it by the magnitude of AB, okay, then I will get a vector which is unit vector in the direction of AB. Okay, so let me find the magnitude of AB first. AB vector's magnitude. Okay, this was my AB vector, so it's going to be square root 8 square plus 15 square. Am I right? Okay, and this will give us 17. So this unit vector, it is going to be AB, which is 8i minus 15j, and divided by 17. Okay, so you can confirm that this vector has magnitude of 1, and of course it is in the direction of AB. Okay, so this was part 2. Now let's do part 3. Okay, the position vector of the point C, no, C is some other point, okay, relative to the origin O is such that OC is OA plus M times OB, okay, where M is a constant. Given that C lies on the x-axis, find the vector OC, okay, so it is given that OC vector, it is equal to OA vector plus some M times OB vector. Okay, so let's try to write this one. OA is minus 2i and plus 17j. Okay, and plus M times OB vector. What is OB? It is 6i and plus 2j. So this can be simplified as I has coefficient 6m minus 2 times I vector, unit vector I, and similarly plus 2n minus 17 times j vector. Okay, this is my OC. Now, interestingly, it is given that point C lies on x-axis. It means that this part must be 0. Right? There should be no j part. Okay. So from this information, I will say that 2m minus 17 is 0. So m is equal to 17 divided by 2. So this is going to be 8.5. Okay. I think I'm making some mistake here. It is 2m plus 17. Why it is, yes, this is plus. Sorry, I have my negative here. It is plus. Okay, 2m plus 17, yes. Okay, so 2m plus 17, so it will give you negative 17 over 2 is negative 8.5. Okay, so now knowing the value of this m, I can find the vector OC. OC is equal to 6 times m is minus 8.5 minus 2. So this whole thing will multiply with I. Okay, and of course, if I put m equal to minus 8.5, this all becomes 0. So there's no j, no need to calculate the j. Okay, and if you calculate this thing, this all comes out to be minus 53, minus 53 I. Okay, so this is our OC vector. Okay, that's kind of this question. Hope you enjoyed this one. Thank you very much for watching. See you in the next video.